There we go. Okay, so problem solving with trigonometry. This is from your textbook 13.4, your essential question, how can you solve a right triangle? And your learning goal is I can find all missing sides and angles for a right triangle using trigonometric ratios and the Pythagorean theorem. So when we say solve a right triangle, you're given a right triangle, and we know there's that 90-degree angle already, but maybe we have a couple pieces of information about it. If we want to solve it, that means we find out the measures of all three sides and the measures of all three angles. All right, so this next slide, I'm gonna have to present it a little bit differently. It's a video. Now, if you had the pleasure of being in my 8th grade math class, then you might remember this. It might be stuck in your head still from then, but if not, then you're welcome, because it's really awesome. And so let me just pause it real quick. I have an ad. I'm going to just present that one tab.
Look at a right triangle with a 90-degree right angle. Across from the right angles, the hypotenuse. It's no surprise the hypotenuse is the longest side. Now, how do you find the hypotenuse's length if you know the length of the two other sides? Let's take you back to old ancient Greece. Pythagoras is gonna show you why. A squared plus b squared equals c squared, where c is the length of the hypotenuse. A squared plus b squared equals c squared, where a and b are the length of the other sides. The Pythagorean theorem is a delicate calculation. To find the hypotenuse, take the square root of the sum of the two other sides squared, and then compute. How do you find the hypotenuse's length if you know the length of the two other sides? Let's take you back to old ancient Greece. Pythagoras is gonna show you why. A squared plus b squared equals c squared, where c is the length of the hypotenuse. A squared plus b squared equals c squared, where a and b are the length of the other sides. A squared plus b squared equals c squared, where c is the length of the hypotenuse. A squared plus b squared equals c squared, where a and b are the length of the other sides.
All right, so that was way less glitchy than it was for first period. I think it's because I didn't maximize the window, and I intentionally did not maximize the window because it was just loading and loading and loading. So I'm going to close that out, and then I'm going to present again. Put down my entire screen. So yeah, that is a catchy little song. You have that in this Pear Deck, so if it's stuck in your head later, you could go back and watch it. I've always shown it in 8th grade, and so it was fitting to show it right now because we do need to remember how to use the Pythagorean theorem. And we're going to use it when we solve a right triangle. So let me make sure I'm presenting what I want to be presenting. Yes, so solving a right triangle means finding the lengths of all its sides and the measures of all its angles. So that's 6 things total. There's 3 sides, 3 angles. To solve a right triangle, you need to know 2 side lengths, or one side length and acute angle measure. That's all you need to know to solve a right triangle. And then based on whatever information you're given, you can choose among trigonomic ratios, inverse trigonomic ratios, and the Pythagorean theorem to help you solve that right triangle. So that's what we're going to be doing, is solving right triangles today. Again, this is not something new. It's just taking everything that we've been learning and also remembering the Pythagorean theorem to do what is called solving a right triangle. Okay, so this first slide here, we can all write on, okay? It's a real life situation. You have a picture here. I try to get everything to fit, so it's a little bit tight, but a shelf extends perpendicularly 7 inches from a wall. You want to place a 9-inch brace under the shelf, as shown. To the nearest tenth of an inch, how far below the shelf will the brace be attached to the wall? So this is like a real life situation that you could possibly find yourself in if you ever hang a shelf on a wall and you want to know, where you're going to attach it. And also, what angle will the brace make with the shelf and with the wall? So our wall is here, it's labeled, it's this vertical line. Our shelf is here, it's labeled, it's this horizontal line, and then the diagonal here, this is the brace that's holding that shelf up. So if we put any weight on the shelf, it's not going to fall off the wall. What we know so far is that we have a right triangle because of this 90-degree angle, and we can see that there are two sides that are labeled. We can see that there's the 7-inch side, which is actually one of the legs, because the right angle is being made up of the two sides. The wall and the shelf are the legs, and the 9 inches is the hypotenuse. So when we are referring to legs and hypotenuse, when we get into those trigonomic ratios and we talk about adjacent and opposite, we're referring to the leg lengths. So it's a matter of perspective of which one's adjacent and opposite, depending on which angle you're looking from. But the hypotenuse will always be the hypotenuse. That one's not going to change based on your perspective. So the hypotenuse is this 9-inch side right here. I'm just going to label it like that. First thing here is we're going to find BC. So BC is this wall length. Let me use brown. So that's this length right here. Okay, because maybe this is just our wall over there. We want to find the length of BC, which is a segment BC. And we have BC squared. And then AB squared, that's the hypotenuse. Notice the hypotenuse squared is always on the right-hand side. On the one side, the equal sign by itself. The hypotenuse is always by itself. But a squared plus b squared are going to be on the other side together being added. And so that's this shelf here. Let me see, what do they want to use a certain color without trying to confuse anybody? I'm going to make it green right now. Okay, so here is the Pythagorean theorem, okay? And basically it's coming from a squared. And, you could type this out too if you wanted to, or use the pencil tool, but it's hard to write the squared. I did have some students that were able to put in the squared symbol through Pear Deck because of a keyboard that they're using. I wasn't able to figure it out, so I don't know if any of you guys have been able to figure that out, but there is a possible way of getting your X bonus to show up. Oh, I don't like that at all. Let me just write it over here. That'll be better. So a squared plus we have b squared is equal to c squared. Yes, that's what they were telling me. And it has to do with like a certain keyboard in your settings that I don't know how to change or haven't tried to change, but yes, it is possible to do that. Thank you, Adriana. And welcome. It's okay that you're late. Yeah, there's something about your keyboard. International, that's what it is. You have to be on an international keyboard setting. So you could try it and see if it works for you, but it doesn't work for me every time I try it. Over here on the left, what we're adding here, these are always the legs. Okay, so your legs of your triangle are always being added together. Doesn't really matter which one's A and which one's B, but notice they're lowercase a and b, and the hypotenuse is always on the other side. Always by itself. Okay, so C is always the hypotenuse. A and B are always the legs. Hypotenuse. I think I spelled that right. Okay, so we're just using, instead of little a, little b, little c, we're using actual side lengths to represent what we're plugging in. And then we're just going to evaluate this. So you replace AC with 7, and then you replace AB with 9. We square those values. Squaring means you multiply something by itself. So 7 squared is 49. 9 squared is 9 times 9, or 81. After you do that, then you're going to subtract 49 from both sides, even though it doesn't really show you doing that. That is what they're doing. They're subtracting 49 from both sides. You know, I could type that in there so you could see it. Okay, so we are subtracting 49 from both sides. And then what we're left with is BC squared equals 32. A lot of students will stop right here and say that, okay, I figured out that BC is 32. But you haven't yet. What you found out is that BC squared is 32. So there is one more step, and that's to undo the squaring. So you have to use square roots to undo the squaring. And that's what we're going to do, is we're going to find the square root and the root. So basically, you just take the square root of both sides. So the square root of BC squared is BC, and then the square root of 32. Okay, and just to show you, you can come to the, I'll show you on the Google calculator. If I take the square root of 32, I'm going to type the square root symbol first, and then 32, and then equals. And they're rounding this amount because it says to round to the nearest degree up here. They say to the nearest degree. All right, so we're rounding, and that's why they rounded right here. BC is approximately equal to 57.7. I'm so proud of our textbook. They actually used the right symbol. They rounded and they put the approximately equal to. Amazing. Okay, so, you know, just through part A, we figured out all 3 sides now. We were given 2 sides, and we figured out the other missing side, which I can label on here. It is 5.7 centimeters about, right? And so when you are solving right triangles, you want to use dimensions that are not rounded if you can avoid it. So as we move into this next part here, part B, we're going to find the measure of angle A and the measure of angle B. All right, so now we're looking for some angle measures here. We're going to find the measure of angle A, and that's right here. This is A. And we're going to find the measure of angle B, which is this guy. So you do have some choices about what you can use to find A and B using, you know, certain trigonomic ratios, but you do want to avoid using anything that's already been rounded. So ideally, you should use 7 and 9. You should use these lengths here because they are not rounded. They are exact measurements. The more you round, the less accurate your answer will be. And that's the reason why you don't want to use 5.7 right now. So to find the measure of angle A, you could start with A or B, it doesn't matter, but this is showing measure of A first. Says the lengths of the adjacent side. All right, the adjacent side I already have labeled to A. The adjacent leg to A is 7 inches. Again, that's based on perspective. Okay, 7 is not adjacent to B. 7 is actually opposite to B, but to A, 7 is adjacent. And we know the hypotenuse. The hypotenuse is always the same. It doesn't matter perspective. It's 9 inches for A and it's 9 inches for B. The hypotenuse is always 9 inches. So based on this, we're going to use the cosine ratio. Now, the way to use cosine ratio is it's probably a good time to just type out SOHCAHTOA. And the reason why that's useful is because it helps us recognize which trigonomic ratio we want to use. So I have adjacent, which is, right here. Here's adjacent. Nope, wrong color. So pencil tool. I have adjacent here. I have adjacent here. So right, that narrows those two I could use. And then I also have hypotenuse. Okay, so I could use this one or I could use this one. But for cosine, this is the only one where I have both the adjacent and the hypotenuse. I know 2 pieces of the puzzle, so that's what I want to use. So we're going to use cosine. That's where we're going to use the cosine ratio to find the measure of angle A, right? Because we have adjacent and hypotenuse. And we just plug that ratio in. The ratio is just, writing adjacent over hypotenuse, which is 7 over 9. So right here, cosine of A is just going to be 7 over 9. All right. Once you write the cosine ratio, then what you can do is, rewrite it so that we're finding that missing angle measure, because we're ultimately trying to find the measure of A. And so in order to do that, we use the inverse cosine ratio, which is cosine with this little -1 exponent. So this is the inverse cosine ratio. And then we just put the 7/9 in here in the parentheses as well. That's 7 over 9. And here's where we're going to use our calculator. Again, when you use the Google calculator, we're dealing with degrees. These measurements are in degrees, so we want to make sure we're on degrees, DEG. And then we're going to type in inverse, or click, sorry, inverse, and then inverse cosine. It'll show up as arc cos, and we'll put in our ratio, 7 divided by 9. Close your parenthesis, and once I hit equals, that's going to tell me the measure of angle A. 38.942441269. So we're going to round this to the nearest degree. So the measure of angle A to the nearest degree is either going to be 38 or 39. So you look over here, I have a 9, which means I need to round up. So it's approximately, and look, they use the right symbol again, approximately 39 degrees. All right, so let's type that right there, 39. That is a huge 39. Let's make that a little bit smaller. All right, 39 degrees. And they use the right symbol. I'm so proud of our textbook. Up here, I could put that also. This is about 39 degrees. Okay. I was trying to not have to use symbols, trying to type it in. So we know this is about 39 degrees. Last thing we need to find is the measure of angle B. All right. And we're going to use the fact that what 2 angles are complementary? Angle B and angle A. A is complementary. Angle A. These are complementary. What does complementary mean? Well, it means that they add to how much? 90. Yes, Adriana. They add 90 degrees. So we're going to put an A here. And then we're going to substitute in what we found out A to B, which is 39 for A. And then over here, we'll just put 39. And we'll solve this little problem here by subtracting 39 from both sides. And that's going to tell us approximately what the measure of angle B is. How much is angle B going to be about? What do you guys think? $51? Yep, 51. All right. All right, so I'm going to put that in here, 51. Let's see, trying to be consistent with all these different colors that I'm using. All right, so 51 degrees. And again, the book put the right symbol. It's approximately equal to 51 degrees. And that is our other answer that we needed. And we have now solved the right triangle because we know all three angle measures. We know the 90-degree angle. We know that angle A is about 39. We know that angle B is about 51 degrees. And we've also figured out the missing side length here. So we've solved this right triangle. Sorry. I'm gonna leave this here for a minute, then we'll move on to the next slide. Do you guys have any questions on what we just did? You can unmute or type them in the chat. Okay, so this is going to be in the recording. So if you don't have all of this down, you can go back and watch the video once it's done processing and add to yours. I still see some of you guys typing though, so I'll leave it for typing or drawing or whatever we're doing here. Let me just put it on student pace so that way you have that. And since it's on student pace, I'm going to go to the next slide. Although you can still see my slide because I have two slides of mine being shown right now. So for this next slide that we're going to do, we're going to solve the right triangle, which is what we just did. But it was like guided. So here there's no guiding to it. But we have a right triangle. And if we solve the right triangle, that means we will find all the lengths and all the angle measures. Okay. All lengths and all the angle measures. And we already know some of them. Okay, we already know that we have one leg is 2 7/10 centimeters. We know the hypotenuse is 3 1/10 centimeters. We know this angle is 90 degrees. Okay, so we have to find what's left to find, basically. We need to find, we want to find the lengths of AC, measures of angles A and B. That's it. All right, so we have three things. We got to find three things. We're going to find the length of AC, then the measures of angle A and B. Where you choose to start, it's really up to you. The Pear Deck code is right here, TVXOBS. Where you choose to start with this is up to you. You can start by finding the angle measures first. You could start by finding the missing side first. Okay. It's okay to choose which way you want to go with this. I'm going to show you guys how to find the missing leg length first, right? So again, I'm going to just do some color coding here. And the hypotenuse is right here because here's my 90-degree angle. The hypotenuse is always opposite the 90-degree angle. I have a feeling I still have the, I do. There you go. There's the Pear Deck link. It's in the chat. So I still had it saved to my clipboard. The legs. So the two sides that make up your legs, it doesn't matter which one's which with the Pythagorean theorem. It's just, you know, on one side of the equal sign, you have a squared plus b squared. The other side, you have the hypotenuse squared. So for this one, I'm going to type and then go back and add in with some drawing tools, the exponents. So we have a squared plus b squared equals c squared. This is the Pythagorean theorem. And then these are just representing the length. So A and B, 2.7 could be A or B, and then the side is A or B. And then this is just C here, okay, because this is the hypotenuse. So we're going to substitute in, maybe we could write it as AC squared plus 2 7/10 squared equals 3.1 squared. Okay, this is one way to set this up. Squared, squared, squared. And then it's very similar to what we did in the last one. We're going to square what we can. Okay, so 2 7/10. On the Google calculator, if you want to use the squared button, you have to click this x to the y power, and that'll give you a little exponent box, and you can put a 2 in there. That's one way to do 2.7 times 2.7. You could also just type in 2 7/10 times 2 7/10. I'm not going to round 7 29/100. I'm going to write that whole thing out. Don't round unless you need to round. The more you round, the less accurate you are. So always keep that in mind. And then 3.1 times 3.1. That's another way to square with the calculator. 9.61. So put that there. I'm not going to forget about my little exponent right here. At this point, I'm going to subtract 7 29/100 from both sides. Oh, I know we're on student pace. I have a lot of you have moved forward to this slide, which is great. I think I'm going to make you guys move forward at this point. Okay. So we're solving for that missing leg length right now. Once I subtract for both sides, I'm left with 2.32. And don't forget about the little squared symbol right there. So AC squared equals 2 1/32. Did I find the length of AC? Is AC 2 1/32, or do I have to do one more step? One more, yeah. AC squared is 2 1/32. I want just AC by itself, so we have to take the square root of both sides. Square root, square root. AC equals. Actually, I don't think it's going to be equals, because when you take the square root of anything that's not a perfect square, you get an irrational number. So if I take the square root of 2 1/32, that is not a perfect square. So I am going to get something that I'm going to have to round at this point. Or I could leave it exact. I could leave it as the square root of 2.32, like that. But I think it says to round. Yeah, so you always got to pay attention to what it's asking you to do. Here it says round lengths to the nearest tenth and angles to the nearest degree. If it asks for an exact answer, then my exact answer would be the square root of 2 1/32. That would be exact. But it wants us to round. So square root symbol, 2.32, and equals. We get this. We're going to round to the nearest tenth, which is 1 5/10. If it was to the nearest whole number, it would be 2. Nearest tenth. If it is near this, yeah, so 1.5. Any questions on why that is the way it is? Any questions on why we rounded the way we did? Anything about what we did here? Okay, so we figured out what AC is. The length of AC is 1 5, about 1 5/10 centimeters. What is the nearest degree? Okay, so nearest degree would mean whole number. Yep. Okay, so now we are going to look at those degrees. Okay, so we found AC. Now we got to find the measures of A and B. Here's A, here's B.
I don't understand this.
Okay. What part did I lose you at? Everything? Or is it a certain part? So do you understand that when we say what it says up here, where it says solve the triangle, it means we need to find all the lengths and all the angle measures. Does that make sense? Right here where it says solve the triangle means we need to find all 3 lengths and all 3 angle measures. Does that part make sense? So depending on your picture, you may have to solve for different things, different times, depending on what you're given. Here we were given 2 side lengths of a right triangle. So we had to find AC, which is this piece right here we just found was 1.5, about 1.5. This was approximately 1.5. We just found that out. Then the next thing is to find all the angle measures. So we know this angle is 90 degrees because of the little box, but we do have to figure out angle A, and we have to figure out angle B. Okay, and it doesn't matter which one we want to start with, but we're just going through Pythagorean theorem, trigonometric ratios. Is that helping? I'm not sure. I think that was Jackson. Was that Jackson that you came off your mic? I'm not too sure. All right, so anytime you're going to start using those trigonometric ratios, it's always a good idea. Write it down. So, which you have, and see which one you can use. Okay. Looking at this picture, well, I do have all 3 sides. I actually have opposite, hypotenuse, and opposite adjacent. But I did tell you guys if you can, so let me put that here too. If possible, do not use rounded measurements in your calculations, because it's just going to get less and less accurate that way. Every time you round and then you use that rounded number to find something else that you have to round, it gets less and less accurate. So we don't really want to use this leg here. We'll use the hypotenuse. Okay, so we can see that we have the hypotenuse. We have the hypotenuse. I don't have the hypotenuse here, so I'm not going to be using tangent. I'm either going to use sine or cosine, and since it's opposite or adjacent, it just depends on which angle I'm going to use. Okay, so if I want to find the measure of angle A, then I'm looking at the opposite. This would be the opposite. If I'm finding the measure of angle B, then this would be adjacent. So it doesn't matter if you use sine or cosine, you just have to make sure you set up your ratio correctly. All right, so let's find the measure of angle A. Okay, we'll use sine. So over here, I have the measure of angle A. I'm gonna find this first. All right, since I'm gonna do this, and I wanna use sine, S-I-N of A. So this is just a ratio. When you find sine of angle A, you're writing down a ratio. Sine of A is opposite over hypotenuse. So from this perspective of A, 2.7 is opposite to A. So my ratio is going to be opposite over hypotenuse. So sine of A is 2.7 over 3.1. Okay, that's division. And since I'm trying to find the measure of angle A, this is where I need to use inverse sine. All right, so I could rewrite this as sine to the -1 power that's inverse sine. And we're going to put the ratio in now of 2 7/10 divided by 3 1/10. And that's going to actually equal the measure of angle A. Okay, So this is what we're going to use the calculator for, and that's going to tell us the measure of angle A. So when we want to do inverse operations with the calculator, we want to make sure we're on degrees. We're going to click inverse, click the inverse operation I want, which is inverse sine. It pops up as arc sine. And I have a parenthesis that's open. I'm going to put in this ratio, 2.7 divided by 3.1, close the parenthesis. And once I hit equals, that's going to equal the measure of angle A. Equals 60.57129, and so on. And we do want to round this. It says round to the nearest degree. So that's talking about a whole degree. You know, so I want to the left of the decimal, 60, or is it 61? Depending on what's right here in the tenths place, I have a 5. So I'm going to round up to 61 degrees. So the measure of angle A is approximately 61 degrees. I know that looks kind of funky, but I'm going to add in what's missing. All right, so the measure of angle A, oops, is about 61 degrees. I can put this, you know, where it goes. So right here, angle A, this is about 61 degrees. And the only thing left to find is the measure of angle B. Measure of angle B. What's this guy? You can use in trigonometric ratio, or we could just use the fact that, hey, A and B are complementary. A plus B is 90. And since I already know this angle is 90, this one's about 61. This mystery amount here, basically, what we're going to do is just add and subtract. So 90 minus 61 is going to be about what the measure of angle B is. Ninety minus 61, 29. So about 29 degrees. That's what is the measure of angle B. All right, so there is one more slide, time-wise. Looks like class already ended. I'm sorry, I'm taking you guys over. I was going to leave the last slide for you to do on your own. Yeah, you're allowed to leave. If you want to stay on the meet, you can, because I'm still recording it. You can go back and watch it. You're going to do the last slide during your async time and this Delta Math assignment. Okay, so finish slide 7 and do the Delta Math assignment. If you want to stay on the meet and see how to set up slide 7, because it's a little bit different, then you can stay. Otherwise, you're free to go. So next slide here, I need to put back on student pace. We're going to solve the triangle, the right triangle, which means find all 3 side measures, find all 3 angle measures. We're going to round length to the nearest tenth and angle to the nearest degree, just like in the last problem. What's different now is that on the last problem, they gave me 2 side lengths to start. Here, they gave me 1 side length and an angle measure to start. So there's different ways to go about it. What I would suggest you might do is when you're given a 90-degree angle and a degree, one of the acute angles, find that missing acute angle, the other one first, because we know that the three measures of any triangle add to 180 degrees. So you can use that to figure out the measure of angle F. You can also use the fact that angle D and angle F are 2 acute angles in a right triangle, and they're complementary, and 56 plus something equals 90. That's another way to do that. All right, so however you want to think about it, find this first, probably. Okay, that's one of the things you have to find. I'm going to find the measure of measure of angle F. We also need to find a couple side lengths here. So we're going to find FE. These are all the things you need to find on this problem. The length of FE. You also want to find the length of DF. DF is the hypotenuse because it's opposite the 90-degree angle. 26 meters, and this side length FE, you know, depending on your perspective, one could be adjacent or opposite, but they're the legs of the right triangle. So can we just 90 minus 56? Yes, you can. 90 minus 56 will also give you the measure of angle F. So there's different ways to solve math problems. Oops. You guys have other questions? Do the paradox get graded? No, I'm using them more for your notes just to present the lesson. They don't grade them. They do count if you try them, that's your attendance. So just participating and joining, that's how you get your full, like, that you were present and you were responsive.